Welcome everyone to Knox Game Design for December 2024. My name is Levi Smith. This month I'm going to be talking about the game Solitaire, also known as Klondike. It's a card game. I'm not going to go through and do a line by line like code review of how to make Solitaire. I'm just going to go through 13 steps that I use to create a Solitaire game in Unity. Just going through my thought process when I was doing that. And I'll also have the code for each of those 13 steps posted online in a code repository. So first of all, it uses a standard playing card deck, 52 cards, 4 suits, spade, club, diamond, and heart. And also the card numbers 2 through 10 with an ace, jack, queen, and king. So the first object that you'll need, or first script that you'll need, game object you'll need, is a card. As I said, each card has a suit, and each suit has a color. Both the spade and the club are black, and the heart and diamond are red. So you can actually derive the color from the suit. You don't need to actually store that value. The suit's going to be an enum, and then the card's going to have a value. So basically what I did is I assigned 1 for the ace, and then the actual number value for the number cards, and then 11 for a jack, 12 for a queen, 13 for a king. You could have started out with a 0 as ace, and then 1 as 2, but that gets really confusing really fast. So that was the easiest approach that I took. Each card is going to have a face up or face down value, whether it's showing the face up or it's hidden. And then we're also going to have an is selected for moving the cards around. The card is going to be a collection in a deck. So a deck is going to be a collection of cards, and basically we'll just have a shuffle method on the deck. And then you're going to have stacks of cards. You're going to have a stock, which is where you draw the cards from. Waste is where you put the cards after they've been drawn, if they're not used. You're going to have 7 piles. Basically, those are stacks on the playing table. And then 4 foundations. So basically, the cards are going to move into the foundations. And that's the objective of the game, is to have 4 foundations, 1 of each suit, with all cards from ace to king in sequential increasing order. So this is what the game, if anyone's never seen Solitaire before, this is what it looks like. Stock and waste in the upper left-hand corner, your 4 foundations in the top, and then your piles of cards. So each pile has 1 increasing amount of cards. So the first pile has 1, second pile has 2, third pile has 3, all the way to 7. 7th pile has 7, and only the last card in the pile is showing. And basically what you do is you start adding to those piles the shown card in sequential decreasing order with alternating suit colors. So if you have like a 7 showing in like one of the piles, and you can black 7, then you can play red 6, and then a black 5, a red 4, and so forth. So this is the first thing you do when you want to make Solitaire. So I got my 3 scripts up here for the 3 game objects, 1 for card, 1 for deck, 1 for just the game manager that does the setup and everything. The card is going to be a prefab, and you can see that right here. These cards are going to be instantiated when the game is started. Deck setup, we're going to create our cards. It's going to be a nested loop. You're going to loop 13 times for each of the card values, and then within that loop 4 times for each of the suits. Don't worry about the name cards starting out. Just assign the values, and then print those cards to the debug log output. So that's the first thing you want to do. Just get your cards created and get them instantiated under the deck right there. So here is a little bit of the code. So here's the game manager with our deck, deck object, instance variable. Then in deck, we're going to have a list of cards, the game object, card prefab. So here's the actual loop right here. I won't go into detail, but that's how you instantiate the cards. And then we're going to print the deck down here. And then in card, it's going to have an enum suit. And then it's going to have a suit value, the is face up bool and the is selected bool. Then we'll have a helper method here to print out the card. So after you have your cards created, the next thing you want to do is just shuffle the deck. That is very important. So we're going to implement a shuffle deck method, shuffle cards method in the deck class. So we're going to select a random index from 0 to the card list size, and then while you still have cards in the card list, we're going to move the card at that index to a temporary shuffle cards list. You'll stop looping once there are no cards left in the deck and all the cards are in the shuffled cards list, and then basically we're just going to return that shuffle card list as the new card deck. And once you do that, you're just going to assume that the old empty list of cards will be garbage collected since nothing's pointing to it. So then basically you just want to do a print deck, and then you can see all your cards with the suits values are shuffled. So that's the second step. Third step is creating the piles in the foundation. So pile, as I said, is a list of cards. Already said this player can only add a card to pile. Select the card value is one less in a different color. The showing card on the pile. Foundation. So you can only add to the foundation if the value, this should be 1 if it's an ace, if the foundation is empty. Otherwise, you can only add to that foundation if your card value is 1 greater and of the same suit. So the game manager is going to start with 7 piles and 4 foundations. Create the pile and foundation scripts. Create an add card. Use the add card method to add to the piles and foundation. I think you could like really use like an implements in here to force each of those to have an add card method, like an interface. You can add a method to get the suit color as well. So here's the pile class right here, foundation class, and the card class. There's the get card color method right there. And then the game manager, you're going to have the list of piles, foundation, pile prefab, foundation prefab. So this is the way I started out developing this. I actually kind of changed it a little bit going through, but that's how I started out right there. Then we have our setup, creating the 7 piles and the 4 foundations there. So basically, we're just going to have stand-in graphics to start out with. Don't worry about graphics starting out. Just use I just use rectangle size 250 by 350. Just a blank white square with a black border. So I used basically a UI image for that in Unity. Then I used a UI text as a child of that to display the card value and the card suit. Basically, update the transform values to get the appropriate size. Create a canvas to display all the card game objects. You have to ensure that the deck and cards are children on their cabinets, or else they won't display. Very important right there. So here's one thing that I found out. So when you're displaying things with the Unity UI, such as images or text, things like that, they display in the child order, not in the Z index. It took me a little while to figure that out. So you can actually use like a set sibling method to ensure those are in the correct order. Just need to do that to make sure that the cards are overlapping in the correct order. So start out, you just want to make sure that you can display all the cards in the deck and verify that they're shuffled and everything looks right. So yeah, this is what I did right here. So this is all 52 cards. Nothing fancy right here. I did break it up into 2 rows, but you can see like 9S for the nine of spades, 2H for the 2 of hearts, 10D for 10 of diamonds, and like KS for king of spades. So you just want to display that the entire deck of cards to the screen. Card selection. I think this was like one of the hardest parts of it. If you can get the card selection working correctly, that was like the hardest part right there. So basically what I did is in the update method of the game manager, have an input, get mouse button down, pass in 0, which means the left mouse button was clicked, do a raycast hit 2D to get a hit object. You're going to do physics 2D raycast. You want to pass in the input mouse position. And if you're doing a 2D raycast, it raycasts it on the 2D plane. So we just want to know where the user clicks, so we're going to pass in vector 2 0. That just means that it's not going anywhere. It's exactly where you clicked. So if you get the hit object back, we're going to display in the debug output where it hit, what object it hit. You can do a hit collider.get component and pass in the specify the, I think that's a template, specify the object or script type of card, assign that to a card object. If that card object does not equal null, then that means it hit a card. So I'm going to use debug log, then pass in that card that was hit, get display value. That's only if it isn't null. But it should display, as you can see here in the output down here, it shows which card was clicked. Just need to make sure that the 2D collider lines up over the card image. So you may have to go in that collider and specify like a width of 250, height of 350 if that's card size that you're using. Already talked about the raycast right there. So this is the tricky part right here that I found out. When you're doing the box collider 2D and clicks on the box collider, the Z position is important. So when you're displaying the images, it's all based on the sibling order, child order, and the transform hierarchy. But when you're doing collision, it is based on the Z position. So that's one of those little quirks about Unity. Just you got to remember. So basically in the code, I just made the card yellow, gave it a yellow tint if it is selected. So whenever you select a card, you need to unselect all of the other cards. So you just need to make a loop called unselect all cards, make a method called unselect all cards, loop through all the cards in the deck, unselect all the other ones when a new one's selected. And you can add a method called get selected card in your game manager. It just basically loops through all the cards and returns the one that is selected. So the next thing that I did was I basically need a way to stack the cards in the piles. So I added a method called get top card to pile and foundation, the very last card in the list. So if it is the top card in the pile, allow the card of an opposite color and one less value to be stacked on top of it. If it's top card in the foundation, allow the card of the same suit and one greater to be stacked. And allow an ace, value of 1 if no cards are in the foundation. Deal the cards from the deck. So basically I move the cards from the deck to make the 7 piles. 1 additional card for each pile. And then the remaining deck is split into the stock and the waste. So whenever you're moving cards between the piles, you can select a card higher in the pile and move like a stack of cards. So that's one thing you got to be aware of. So I actually have that assigned to a list of cards. Move that selected card into a card list. The card that's selected and all the cards underneath it. And basically at step 6 right here, what I did is I kind of redid the code. So instead of using list of cards for like the pile and the foundation, I did everything by the hierarchy, the transform hierarchy. So if a card is a child of a pile, child object of a pile, then I know that card is in that pile and there's no reason to create a separate list of cards in the pile script. Same goes for the foundation. If the card is a child of foundation, then there's no need in the foundation script to create a list of cards. You can use the get children of that game object, pass in the card type or using a card template instead of keeping a separate list of cards, which is a little bit redundant. So the next thing I did is I added 2D collider around the foundation location. That way you can click on it. If your current selected card meets the requirements of being put in the foundation, then when you click that foundation, then it gets moved. It gets moved as a child, as the last child in that foundation. Set the parent of that card to the foundation using its transform. Then you need to update the local position of the transform, the card that's being moved into the foundation, to vector 2.0. So wherever the location of the foundation is, that's going to be the new card position. And also you need to update the Z position. So you need to, as we stack cards in this foundation, we're going to subtract. It can be any value. I'm using minus 0.1. So each card in the foundation, as it gets stacked, is getting stacked minus 0.1 in the Z direction. So it's kind of cool. It is 2D, but if it was 3D, you can think of it like the cards are coming out of the screen toward you. That way, whenever you click on it, you know you're clicking on the top card in that foundation. And you're adding cards to that foundation. Step 8. So the step 8 that I did of basically moving cards from the stock to the waist. So I added a 2D box collider around the waist area, which I just have as a red card right here. When the waist is clicked, you're going to add the top card from the stock to the waist if there is cards in the stock. And once it's the transform of that card to the waist position, update the local position to vector 2.0. I actually want to set that card, move it from the stock to the waist by using the set parent method of the transform of that card. We're going to move it, set the parent is currently the stock, so we're going to move it to, set it to the waist, and then update the local position of the card to vector 2.0, which is the location, moves it over to the location of the waist pile. So if there's no cards left in the stock, whenever you click the waist, it's basically going to move all the cards using the transform. Set parent's going to go through all those cards and set the parent for all the waist cards back to the stock object. So we could have did this earlier. It just depends on what you want to do first. You want to implement moving stock to waist first, or you want to implement the piles first, or do you want to implement the foundation first? You can kind of do it whatever point you want to. So this was a little bit tricky. So one condition in Solitaire, you have to be able to move if a pile is empty. It allows you to move any of the kings, card value of 13, over to an empty pile. So we do need a 2D collider around pile, and to have those shown in green right here. Set the pile collider to Z position 0, so you can click on it. So let's track 0.1 and Z position for each card in the pile. So I do have like a set card position methods that sets all those positions of the cards correctly. When the pile collider is clicked, so you want to check the first card, the top card in the selected stack, and if that card has a value of 13, if it is a king, then you're going to move all the cards in the selected stack over to that empty pile. Step 10, this is where we're going to implement the face-up card state. So we do have a Boolean to track whether the card is faced up or face down, but we really haven't done anything with it yet. So basically in our card prefab, we're going to have one image, the image we've been using of the card, and then the text value. But next to that, as a sibling, we're going to have an image face down. And so I added a set face up method that takes a Boolean as a parameter. So if it's face up, then we're going to activate the game object of the image card face up. And then on the image card face down, we're going to set its active state to false on its game object. And basically just the converse, the opposite, or if the card needs to be set to face down. And the only time you're going to set it to face down is like when you're moving cards from the waist back to the stock. Otherwise, you're always flipping down to up. So basically, when it's face down, we're not going to show the card's suit and value. So for the last card in each pile, the bottom card in each pile, we're going to set it to face up. Otherwise, they're all going to be face down. By default, all the cards are in the face down state, not showing. So at the start of the game, then you'll show that very last card in the pile, the bottom card in each pile, or when the highest face up card in the pile is moved to a different pile or a foundation. So if all the cards in the pile are face down because you moved one of the cards to a different location, then you're going to automatically flip up that last card, face down card in the pile. So we're going to set the card at the top of the stock to face up, the very top card to face up at the start of the game, or when the top card of the stock is moved to a pile or foundation. As I mentioned, whenever moving cards from the waist back to the stock, then we're going to set all those cards back to face down. And this is also important. Do not allow a card to be selected if the face up is equal to false. So after we've done that, we got a kind of a working solitaire game. So now you need to look at whether the player has won the game or not. There's a few different ways you can do this. The slowest, check through all the cards in each of the foundations. Make sure that they're of the same. If you're assuming that the rules of the game have been followed, nobody's like hacking or cheating or anything, then you can assume all the suits are going to be the same for one foundation. So you just need to check for each value. It goes from 1 to 13. A faster method, the top card in each foundation has a value of 13. So you're just checking the very top. You're assuming nobody cheated or hacked or anything. If the top card in each of the 4 foundations are kings, you know the players won the game. The fastest is assuming that if you have each of the foundations have 13 cards and you're assuming the rules of the game have been followed, nobody hacked or anything, then you know the players won the game. That's the fastest. Just check all 4 foundations for 13 cards. It just really depends on, and I kind of implemented all 3 options right here. So once the players won the game, you're going to display a win message. I just had it as a Unity panel game object, and I just enable that whenever those conditions are met. So the next step is removing debug and test any debugger test. So when I was implementing this, basically I didn't have the check for the alternating black and red cards, so you want to enable that to make it a true solitaire game. Make sure you're checking all 13 cards, things like that, debug, things like that you can remove. And the very last step is that I did in this demo is adding the card graphics. So I went to opengameart.org. It's a pretty good site. They had like a zip file that just like playing cards that I used. Imported all of those 52 cards. And actually had some additional cards. I just used the 15 regular playing cards. Imported all those as sprite objects and under the card prefab. So I created a public list of image objects in the card script. So based on the suit, you can see the switch statement I have right here. Based on the suit and the card value, I know which index to enable and under the card. So it's okay. It's just like 52 child image objects, and you're just going to enable the one that matches the suit and value of that card. That's the way I do it. There's probably plenty of different ways you can handle this, but it seems like it's the most efficient way. So I have this slick little switch statement down here. So basically I do I value, the value of the card -1. So that shifts the ace down to 0, and a 2 down to a 1, and a jack down to a 10, and a king down to a 12. And then I add an offset 0, 1, 2, 3, or 4 based on the suit of the card. So in that list, you're going to have like ace of spades, ace of clubs, ace of diamonds, ace of hearts. It's going to be indexes 0, 1, 2, 3, 0, 1, 2, and 3. And then the next one's going to be the 2 of spades, the 2 of clubs, the 2 of diamonds, then the 2 of hearts. So that's going to be indexes 4, 5, 6, and 7, then so forth, all the way up to 51. So last index will be 51, which would be the king of hearts. Yeah, so you're going to have to update the highlight code to set the highlighted color of the image object. Make that change. So here's what the final, and I'll show the demo, but here's what it looks like when I, at the top, when I added the card graphics, replacing the stand-in, just like the, so it looks pretty good right here. It actually kind of looks like a real solitaire game. Then I went in and added like a background, table background, another open source image, and some images for the card, the backs of the cards, and the foundation areas and the piles. So it actually looks pretty good right there. What next? What didn't I do in this demo? I didn't implement card dragging. I didn't implement sound effects for music. That'd be nice to have. And also do things like add a timer to know how quickly you completed the game. I didn't add like a reset. That'd be pretty useful to have. I didn't add a title screen. It'd be nice to have a score, points, and maybe even a leaderboard. So I'm going to show like the final portion of the demo, but I do have this broken out into the 13 steps. I didn't show the code in these because every time I just exported like the assets folder for each step. The thing about Unity, if I was to try to open this, then it's going to make like a 1.3 gigabyte worth of files in here to open this, which is a lot of space to waste. Makes it kind of hard to show each of these. I was planning on showing these throughout the talk, but I'll just show the final step right here, which is right here. So here's Unity. So we got the 3 prefabs, the card, foundation, and pile. Just have the one game scene right here. Here's the scripts. So I have the card, deck, foundation, game manager, pile, stock, and waste. Here's the sprites right here under assets, and then all of the 52 cards right here. So if we go back and look at card, as I mentioned, here's the card prefab right here, and here's all the disabled images. And then there's the card front list right here with all the 52 objects right there. So that's really important because each of these images, it's going to have an image component to it, and it has, and that way you can like drag one of the items from that list. It'll let you be able to pick one of those image objects. So that's something to watch out for. That's really confusing with the Unity. So when you're specifying the image, you can't just use an image out of sprites. You can't just pull it in. The sprite has to be like signed to a game object, even if it's disabled. So you can pull those in right there. So here's the game right here. Press play. Going to maximize it. So here's the playing field. So we got an A. So basically just click on it, then move it to a foundation. That's automatically going to flip over the bottom card in that pile. You got a 5 and a 6. So this is a little bit different than some solitaire games people may have played. You just click. You don't drag. That's one thing I didn't implement. That'd probably be the next thing that I add to this is dragging. But it is a functional solitaire game. You can move these from different. So you can move the 2 of clubs here up to the ace right there. 8 So you can move that 7 over to the 8. So if I had a king, I'd be able to put it right there. Then I can click the waste up here to start going through the cards. We've got a 3, we can put that on the 4. We've got the ace right there, move him over. A 2 of hearts. Move our 2 of diamonds over here. Then 3. Do the 6. That really doesn't help us. 9. Kind of looking. Move our jack down, I guess. 5. Doesn't help. Kind of looking for a red. Yeah, here's a black king. Let's see if I have a red king in here. Yeah, there's red king. Move him over. So always try to move the cards over that are covering up the most. So if I just have a 3 of diamonds, I'd be able to move. So I'd move the 4 down there. And the 3, go ahead and move him up to the foundation. 10, I need a red jack for the 10. 8. 9. 10. Is that going to help us? Go ahead and move our 10 over, I guess. I always try to work on moving the cards in the piles before I move them out of the stocks. King. 5. So I can move the 5 here. Then that'll let me move the 4 over. That just gives me another black queen. That's really not helping. Black jack. The 9 going to help us. Yeah, that helps us because we can move the 8 over. So now we got a red jack. So I'll move him over here. Then move our 3 up. And 5. I can't move the 5 anywhere. 6. I can move the 6 down. 5 over. The one thing that I found out is like when I refresh the stock from the waste, I think it's doing it in opposite order, so I need to reverse the loop for that. Got a red 6. And go ahead and move our 3 down, I guess. I'm looking for the ace of hearts. Kind of eluding us here. I got a 9. Yeah, when that 8 comes up again, I'm going to move the 8 here. It lets me move the 7 over. So I need it. One of the kings move down here and move the 2 of hearts there. Do I have any kings left? Yeah, there's a king right there. Yeah, so move the king down. Move the red queen over. So there's our 2 of spades. Oh, there's our ace of hearts right there. That's going to help out a lot, and I'm going to be able to move all these up. 3 of hearts to 4 of hearts to 5 of hearts. 3 of spades and the 4 of clubs. 4 of diamonds, 5 of diamonds. Looking pretty good so far. 6 of diamonds. That's going to let me move another king over. And move the 10 of clubs. That's one thing that could be improved. It could like space these cards out a little bit more. But I can tell what they are already. That gives us 8 of diamonds. There's our king of hearts. Move the queen over. Now we got our 5 of clubs. I move that to the foundation. 6 of hearts. 6 of clubs. 7 of hearts. 7 of clubs. Okay, so now I can move the 8 of hearts up to the foundation. Then I can move this 8 that's covering a card. Yeah, so that opened up that one up. And I have a king. You can move the king between the piles if you want to. Really no point in doing that, but Just shows that it can be done. Where's our 10? Spades. 8. 8 of clubs, move him over there. Move our 5. Looking for a 4. 8 to the 7 down. There's our queen. There's our jack. Couldn't move her. So I'm looking for a black 8. Oh, so I have the red 7. I move that to our black 8. Then move the jack over. No, I can't move that jack over. So I'm gonna have one left that's covered up. Bet it's our 4 of spades right there. Move my 10 of diamonds. So I'm going to move my 10 of spades down. So that lets me move my 9. So now I pretty much won. You pretty much won after you uncovered all the cards. Now it's just moving them up to the foundations. We got our 5, our 6, and our 7 of spades. 7 of diamonds. 8 of diamonds. So now it's just going through and doing all of each number. So here's our 9s. Then our 10. I got one more 9. 9. Then our 10s. Move all the 10s up to the foundations. Then our jacks. Move the jacks up to the foundations. Then our queens, move all the queens up to the foundations. Then our kings. You win, yay! Yeah, so that's basically a functioning solitaire game in Unity. Like I said, I'll have the code out there on that knoxgamedesign.org, link to it if anybody wants to take a look at it. But yeah, I definitely recommend implementing Solitaire if you're new to game development. This probably wouldn't be my first game to try to implement, but this is a good test. I mean, hey, I can make Solitaire in Unity or whatever game development environment of your choosing. It's a good game to try to implement that tests a lot of different shuffling a deck, random numbers, moving items to different collections, and testing win conditions, things like that. And it isn't real time, but you can do things like add the dragging. It also shows that you can implement a game using point and click controls and things like that. So hopefully everybody out there found it interesting. Appreciate everybody out there listening and watching. I'll plan on being back in a month.